Returning to this idea of general and vertex form, we have our general form in which everything is simplified. We have totally separate terms, and we have our vertex form in which we have some grouping, right? We have that squared expression including x instead of having just x squared by itself. Looking at a function, we want to identify it as one of these and then apply the appropriate procedures. If we're working with something in general form, generally the way we start is with the vertex formula. If I have something in vertex form, I would not start with the vertex formula because I would have to first multiply everything out and get it into general form in order to do that. And it's actually sort of a gift that it's given to us in this form because we can see the transformations. This is written in a form where we can see what the horizontal and vertical shifts are, so we just identify those in order to find the vertex. Figuring that we start with y equals x squared, which has its vertex at the origin. If I know what the horizontal and vertical shifts are, I can figure out where that vertex got shifted to. So, shifts. Okay, so looking at this first function here, x squared minus 6x minus 1, I would recognize this as being in general form because I don't see any grouping. So I'm going to say a is equal to 1, b is equal to negative 6, and c is equal to negative 1. We generally don't use c in the vertex formula. And go ahead with my h equals minus b over 2a formula. So h in this case is minus negative 6 over 2 times 1. This again turns out to be a positive value. And k I'll get by plugging h into my function. So f of 3 gets me 3 squared minus 6 times 3 minus 1, which is 9 minus 18. Negative 9 minus 1 is negative 10. So my vertex is at 3 comma negative 10. And my leading coefficient I find by looking at the leading term. The x squared term has a coefficient of 1 because there's no visible number being multiplied by it and there's no sign. So we would just say the leading coefficient in this case is 1. And by the way, a in both of these formulas is the same. So the leading coefficient in general form is also the number that is at the front of the expression that is multiplied by the squared term in vertex form. Looking at this next example, I can see there is some grouping, and I can see that it does match up to a times x minus h squared plus k. So all I need to do here is identify the transformations. I can choose to match it up with the formula if I want to. That's one way to find the vertex. But you have to have the formula exactly right in your head in order to do that. And since we know transformations more generally already anyway, I find it to be a little bit safer to just stick with transformations. This 2 that's subtracted directly from the x variable is going to give us a horizontal shift. And we want to remember that those horizontal shifts always go in the opposite direction from what we might expect. So because it's negative, we might be thinking it would go in the positive we might be thinking it would go in the negative direction, but in fact it goes to the positive direction, which is right too. And that 5, which is subtracted on the outside, is a vertical shift. The vertical shifts go in the direction that you would expect. If it's negative, the parabola goes down. If it's positive, the parabola goes up. So this is going to be a shift down 5. Now if we picture the origin shifting right 2 and down 5, we can see that that would get us to the point 2, -5. My leading coefficient, as we already mentioned, is still going to be the number that's multiplied by that squared expression. So my leading coefficient here is 1/3. Without even drawing this graph, I can already picture it. The vertex would be at 2, -5. This graph would open up, and it would look a little bit wider than your standard y = x² parabola because of that vertical shrink or compression with that fraction leading coefficient. Now you might pause the video and take your best guess on these next two and then go ahead and resume to see if your answers agree with mine. Looking at this first example, we actually could consider this to be in either form. If we don't have an x term, meaning we don't have an x to the power 1 term, we have only an x squared and a constant, then we can really play it either way. Most students would start out saying that this is general form because it looks more like general form just to glance at it. But really it's a little bit easier to recognize this as vertex form where it just doesn't have a horizontal shift. So that's why we don't see that grouping that we normally see in the vertex form. If we were to think about the horizontal and vertical shifts of this, we would see that there is no horizontal shift because that x is just directly squared. There's no number that's added to or subtracted from x. And we can see that there is a vertical shift. This 6 added on the outside after squaring is a vertical shift up 6. So if I don't move at all in the x direction and I do move up 6 in the y direction, then I can see my vertex would shift from the origin to the point 0, 6. And my leading coefficient, again, is just the number that is multiplied by the x squared or by the whole squared expression, which in this case is -2. And if you did use the vertex formula instead, here's what that would look like. Note that it's still pretty quick. It does still get us the same point, 0, 6. But it's not quite as quick as just glancing at the thing and seeing that it's shifted up 6 and knowing the vertex right away. So either of these methods is okay. Looking at the next one, I would say this is definitely in vertex form. Even though I don't see a number added on the end, that just means that we really have a 0 added onto the end. This is now exactly in vertex form. We can identify everything a little bit more easily. We do have a horizontal shift because the horizontal shifts are the numbers that are added and subtracted directly to the x variable before squaring. So this is a shift right 4. And we don't have a vertical shift. Therefore, my vertex is at 4, 0. And my leading coefficient is the number multiplied at the front here, multiplied by the squared expression. That's going to be a -1. So these cases where we have no horizontal shift or no vertical shift, sometimes they don't look exactly like the formula to us at first glance. And that's where we need to be comfortable enough, maybe by getting lots of practice with these, we need to be comfortable enough to still be able to recognize them.